Good morning, everyone. Thank you for being here this early for this talk. Yes, we'll be talking a little bit about how to interact with substrate chains using JavaScript and Python. And as Raphael said, and thank you for trying to pronounce my last name. Nobody tries that. I'm the support and anti-scam lead at Web3 Foundation. And the reason I'm mentioning my title is to let you know that I'm not a developer. And this is important for two reasons. The first one is that if you ask me any sophisticated developer questions, I might not be able to answer them. But the second most important reason is because the scripts that I'm going to show you today are meant to be built by basically non-developers in order to help them do their job more efficiently, better, and do stuff that they would not be able to do manually otherwise. So today, we'll be talking about these two libraries, Python and JavaScript. Okay, it doesn't work over here. But there are libraries in other languages as well, and if you scan that QR code, you will be taken to the wiki page where you can find all these libraries and other tools to help you do your job as developers. So without further ado, let's start with the Python library, Substrate Interface. This is a library developed and maintained by Polkascan and funded by the Polkadot Treasury. And basically, as the name suggests, it's an interface library written in Python that allows you to interact with substrate chains using Python. I'll leave these two QR codes a little bit over here, the repo of this library and their very detailed documentation. And I'm going to be showing you a practical example of how you can use Python to automate repetitive or cumbersome tasks that are difficult to do manually, or at least it would take a lot of time. So this script over here was written by Bill because he wanted to send his Bill coins to a bunch of people, right? So whoever asked, he would send them some Bill coins, but if he had like 10, 20, 100 addresses, as you understand, it would be time consuming to do all these transfers manually. So he built this little script over here. And I'm going to dive right into the code. And as this nice comment over here says, the execution starts here. So basically, this script can be run from the command line, and it takes a few arguments, like the asset ID, 223 for Bill coins on Kusama Asset Hub, the amount that you want to send, a file name of this file here that contains the destination addresses where you want to send your funds, and the seed phrase of the sending account. And it also can take a flag to indicate whether we want to send it on the Kusama Asset Hub or the Polkadot Asset Hub. At the top, we obviously import the library and the necessary modules from the library to interact with Substrate. And the first thing that we do is that we create this Substrate object that takes a URL argument, which is the RPC provider that we want to connect to. And using that object, then we can do all the interactions that we want by calling the specific methods of that object. Then we create a keeper using the keeper object. And finally, then we open the text file. We read the addresses from the text file. This is, pretty trivial, nothing special happening here. And then we call this function. The first one is to create a batch call to send the existential deposit to the account to make sure that the assets will arrive because they are not sufficient. And then another batch call to send the actual assets. And we pass, as you can see, the keeper and the destination list. And over here, we also pass the asset ID and the amount. So if we look into these functions, and also, we check this if the address is valid in a kind of, silly way, as Bill says in the comment, we basically try to send to that address, and if we get an exception, then it means that something is wrong. Not the best way to do it, but there you go. So over here, we build basically the call. We loop over the destination list, and we build with the compose call function method a balances, transfer, keep alive extrinsic, and we provide the parameters, which is the destination and the existential deposit, and then we append it to the array. And once all the calls are in the array, then we compose another call, which is a utility batch call. We create the batch call from the individual transfer keep alives here, and then we create a signed extrinsic with a call, the key pair. It's what it's called. It's period that the extrinsic will be valid for, and then we submit the extrinsic and wait to get back a receipt with, and we read the extrinsic hash and the block hash to make sure that we have that information to check it on the block explorer. And actually, if we go to subscan, these are two calls that I made a few days ago, sending the extensile deposit and then sending the actual bill coins to a couple of my accounts. And the same thing happens here. Once we send the existential deposit, then in a very, very similar way, we create these transfer keep alive calls with the asset ID, the destination, and the amount, create the batch call, create and sign the extrinsic, submit it, and get back the results. And this is it. As you realize, this is a very simple script that its purpose is to make our lives easier, right? We could do this manually, but if you have 100 addresses, it might not be that trivial. So if there are any questions, please feel free to interrupt me. Otherwise, I'm moving on to JavaScript. And I think that this library needs no introduction, like Polka.js. Everybody knows it, developed and maintained by Parity. Polka.js, the repo and the documentation. Obviously, it's a whole suite of libraries. We have the apps, we have the API, we have the extension. We'll be focusing on the API today that we can use to build scripts using JavaScript. And I will show you a somewhat more complicated script that I wrote that aims to sort the accounts in the last bag for the nominated proof of stake election. But before I go into that, a quick note, in case you don't know, Polka.js apps has an integrated JavaScript tool over here that you can use to write small scripts, so that you don't need to, if you want to do something very, very quickly. So let's go into this script, but before I do that, a little bit of context in case you don't know. So with MPOS, we can get only 22,500 accounts to participate in the election. The accounts are put in bags, what we call the bags list. And these bags have upper and lower limits, and the accounts are inserted based on their stake in the proper bag. Then the runtime takes all the bags from top to bottom, iterates over the accounts, and once it hits 22,500, it stops. These accounts participate in the election and get rewards. Everybody else doesn't. The account with the lowest stake in this 22,500 defines this minimum active stake. Now, the problem is that in the last bag, some accounts with higher stake might not get in the active set because the accounts within the bags are not sorted based on stake. So we get requests in support like saying, hey, Why am I not getting staking rewards? And the answer 99% of the time is because their account was below the last account to participate in the election. Thankfully, there was an extrinsic that you could call put in front of to put yourself in front of an account with a lower stake that is higher in a higher position within the same bag. But this was not clear, it was not straightforward for the users, and it created frustration. So I thought, okay, how can we solve this to make lives easier for the users? I talked to Kian, he was kind enough to create a PR that introduced a permissionless version of this punti front of extrinsic. So then I went and created this script, which basically what it does is what is described up here. We iterate through all the bags to get 22,500, and we get the last bag and the last account, and we can sort that bag then based on stake by using a batch call of punti front of other. And then when the actual runtime does this, it will, all the accounts above the last account will have a higher stake and be in the active set. So this whole thing is scheduled to run daily just before the election starts. So the first thing that we do, similarly to the Python script, is that we initialize the API. We create a WS provider, an API, and then we return that API and pass it around within our functions to connect to the API and query the state. So the first thing that we do is that we basically do what the runtime will do. We take all the bags, we query the whole list over here, and then we get the bags threshold, which define the upper limits of the bags. And as you can see, here we create a balance type, which is very similar to a big number. And then we iterate over them. We put them in an array here, and we sort the array based on stake, on the score, and then we iterate over them until we reach 2,500 accounts. And that gives us, last index, it gives us the position of that account in the last bag, as well as the last bag itself by calling this small function over here. So once that's done, then we get the accounts in the last bag. Again, we iterate. As you already realized, this cannot be done manually, right? So we iterate over the accounts in the last bag, starting from the head, the first account, and working our way downwards, and we create this object. And as you can see here, we have some very helpful methods. Sorry, let me move the cursor. Because all these are scale encoded, but the JS library provides these helpful methods to translate these to human readable, stuff, like an address, a number for the score and the bag upper limit. And once we have done that, then we first try to see if there are any accounts that need rebugging. So the accounts, under some conditions, like for staking rewards or slashing, will not move in the proper bag. So there could be accounts in this last bag that are not supposed to be there. They belong either in the previous bag or the next bag. So what we do here is basically we iterate over the accounts and see if any of them are outside the limits of the bag they are into, and we put them in an array in order to, call the permissionless rebug extrinsic and move them to the proper bag. And then we call this function do rebug fees. And over here, this is interesting, we create a new promise, and similarly, we create a batch call, this is an array, and we push within it from the API a transaction, voter list palette, rebug extrinsic with the account ID. And then we create a force batch call from the utility palette with this array, and we call the payment info method to get an estimation of the fees. And just below, we have the do rebag that actually issues the extrinsic, its sign and sends, and then subscribes to the status of the extrinsic to give us the status, the hash, and once it is finalized, we loop over the events of the extrinsic to check if the batch call succeeded, it had errors, whether it failed, whether the extrinsic itself succeeded or failed. And this is a standard thing that people do to know if their extrinsic succeeded or failed. And then, once that's done, then basically we have two methods. I'm not going to get into much into that because there's nothing really going on there except playing around and moving around within the arrays. But basically what we want to create is this put in front of array that has the pairs of the accounts, the heavier and the lighter, that needs to be repositioned one in front of the other. And we either do it where we sort all the accounts, and that's the straightforward way, but we get a lot of calls in the batch, so that's expensive. Or we use a smarter way where we find the proper place, we find the account that's supposed to be in that proper place, and then by doing a put in front of, we place it in that place. Then all the accounts that have a higher stake are put in front of, and all the accounts that have a lower stake remain below. These accounts are not sorted, but we really don't care. And once that is done, then we go back to, and we basically do the same thing. We create a batch call of transaction voter list put in front of other. The arguments here are the heavier account and the lighter account. We get the fees for the batch call, the estimation, and then we issue the actual extrinsic. And as before, we get the status, the hash, the events to make sure that everything was run properly. So that's basically the idea. And it helped us to help these users, because that's what we do in support, in this way, so that even if they don't know it, we make their lives a little bit easier and our lives a little easier, because you don't have these frustrated users coming in and say, why am I not getting staking rewards? Okay, I was reading this, that I had less time than I thought I had. So what this script does, basically it calls these functions in order and does a bunch of logging and rechecking, as sanity checks. So once we do that over here and find the last account and the last bag, we simply log it, then we get the accounts in the last bag. And once we do the rebugging of any accounts that need rebugging, then we recheck to make sure that we didn't move, basically, by removing a couple of accounts from the bag, that we did not find ourselves in a different bag all of a sudden. It's quite rare, an edge case, but it could happen. And then, like I said, we use either this method or the full sorting method to generate this put in front of array and get the last account. And then again, we do the repositioning, recheck, some sanity checks to make sure that everything was done properly. Now, one edge case, perhaps some of you might have thought of that. As I said before, the minimum active stake that people see and think, okay, I need to stake above that in order to be in the active set, is the lowest stake within these 22,500 accounts. So it could be that the account with that lowest stake is not in the last bag. This is an edge case. It could happen because of a slash. Sorry. In that case, the account would not move from the bag. It would need to be rebagged. And that's an edge case that the script does not account for yet. I need to go back and work a little bit more on that. But yeah, that's the general idea. Any questions? Yes, please. Wait for the mic.
Yeah, great script by the way. But and that was really helpful because I've always heard this bags list concept, but I never saw the explanation anywhere.
You can check these 2 articles, by the way.
Yeah.
I'll share the presentation. Yes.
That's
sorry.
good. No, the question is, you said this is run daily.
Yes.
How much is paid for fees daily for fixing this?
Very good question. So the first iteration was the simple one. Sort all the accounts in the bag. And I thought, okay, the first run would cost a lot, and it did, like 11 DOT in fees. But I thought after that, okay, we'll probably not pay because you have a couple of accounts. What I did not account for are the rewards. So an account would just get marginally over the next one. So you had a bunch of repositions, and we ended up paying about 2 or 3 DOT per day. So that prompted the other algorithm that I mentioned. That one fluctuates, but I would say we haven't paid more than 1 DOT, and we usually paid like 0.2, 0.3 per day.
Nice, thank you.
Any other questions? Yes.
Hello. I'm just wondering if we could have access to the script, the Python script that you just shown us.
Yeah.
Is it open source? Okay, thanks. That's it.
Yeah, obviously, the script that Bill wrote is something that anyone can use. I don't think anyone wants to actually run this because it's very use case specific. But you know, I thought that it's a nice example of what you can do using Polkadot.js. Any other questions? Yes, please.
On the Python side, do you plan to, or is there a library, like a proper structure library? Because I see, like in your script, you have built the
Yes.
transaction by hand, and is there a library doing that?
Yes, it's this one, Pi Substrate interface, that's developed and maintained by Polkascan. And it's actually, you know, because we had Polkadot.js since forever, this library is very, very useful for, you know, Python people that don't want to, you know, deal with promises and async functions and stuff like that.